Step 7, describing segments. Next we want to look at descriptor variables which are metric, and this means we can now use visualization methods. We have already looked at for metric variables where we have seen we could use a histogram or a box plot, and what we are doing is we're splitting our data set by the categorical variable indicating segment membership, and then we generate, for example, a histogram for each of the subsets. And this is conveniently implemented in the package Lattice, which has the function histogram. And we say we want to have histogram for age, where we split, the pipe here indicates split by, and here we want to use the variable C6, and we just use paste and factor to get nice labels in the strips of our panels. And we want to evaluate the formula here using that data frame, VAC-mod desk, and stable equals true. That's a logical, which is either true and false, and which indicates how should be the panels filled from top to bottom or from bottom to top. Let's look at the age distribution for our 6 segments. So this is what the lattice plot looks like. So we get for each segment, we get a histogram, and each of these subgraphs is called a panel. And the advantage of lattice is that it uses the same limits for the x-axis, where we have age here for each of the panels, and it uses the same bins for each of the panels. So that makes it easier to compare. And here the height is the percentage of total which are contained in each of the bins. Overall here it's very hard to see any strong differences between segments in age, so this is not very informative here, but we could look also at the obligation variable, not the categorized variable but the scored variable. And what does the histogram look like here? Because we've already seen for the ordinal variable moral obligation there was quite a distinction, and again we can see here segment 6 contains a lot of respondents with very high levels on moral obligations. Because histograms are quite hard to tune and might be a lot to look at in that context, the more simplified version is to use parallel box plots. This is what we use here. We will now look at box plots for age by the cluster membership. So we'll split the dataset again by cluster membership, and we'll create a box and whisker plot for each segment for variable age. The formula again will be evaluated using the data argument. That's our label for the x-axis, and that's the label for the y-axis. So this is the result here, our parallel box plot. So we get 6 box and whisker plots next to each other, and this should enable us to easily compare the medians and the overall distribution, in the sense, do they differ in variation? Do they differ, for example, in the length of the boxes? Here one might only have a slight indication that those in segment 5 are slightly less old, and segment 6 contains respondents who are slightly older than the others. And the same we can do with moral obligation. And here we also set var width equals true, which means that we want to have the box widths represent the segment sizes, so we can also get the information included of which is the smallest segments, which is the largest segment. And notch equals true includes a confidence interval for the median estimates. If we want to compare, is there a significant shift in the median between the two groups, we can look at those confidence intervals and see if they overlap or yes or no. And this is again label for x-axis, label for y-axis. So let's have a look. What does this look like? So here, this is called the notch. And this is the confidence interval, the 95% confidence interval for the median estimate here. And if they don't overlap, so here there seems to be an overlap, but so cluster 6 and cluster 3, there don't seem an overlap in the median, so there would be a significant shift in the median moral obligation values between these two segments. And we also see that the box widths are slightly different, and this is the smallest segment. A third possibility to include the information on a descriptor variable is we can also include that information in our segment level stability plot across solutions. So this can be constructed with SLSA plot. So the method we looked at section 5.5.4.2, and we're using the information of moral obligation values for each of the clusters in the node color. So this is our solution with 3 to 8 clusters. We are looking at the sequence in stability across solutions, so that's the normal SLSA plot, but the node color here is now colored. The redder it is, the higher are the moral obligation values for that segment. And we see example for example for the 6 segment solution, 6 has the highest moral obligation values, followed by segment 5.